In this video, we will talk about how BGP finds the best path. BGP is one of the most important protocols for connecting different autonomous systems most of the time, guys. Routing protocols use various algorithms to find the best way to the target network. BGP finds the best path by using BGP attribute parameters. So for example, RIP uses the hop count to find the best way, and OSPF uses the cost value for the metric calculation. However, metric calculation of BGP is not as easy as these protocols. So BGP attributes are the way to label incoming or outgoing BGP routes. While some of the BGP features are supported by all vendors, some of them are only specific to certain vendors. So some features are not traversed while others are traversed from one router to another. The mandatory features are the features that must be included in BGP update message. Okay, so they are AS path, next hop, and the origin. So AS path is basically a list of autonomous systems that a route has traversed. It helps in loop prevention and path selection by showing the AS path that the route has taken. So it ensures loop-free routing and influences the route selection. So shorter AS paths are generally preferred. The second feature, which is mandatory, is next hop. That is the IP address of the next router in path to reach a particular network prefix, and it is used to direct traffic to the correct next hop router. So it is crucial for routing packets to their destination. And we have origin as mandatory. It indicates how route was learned. So the possible values are IGP, EGP, or incomplete for origin. And origin provides information about the origin of the route, helping to prioritize routes. So IGP is preferred over EGP, and it is preferred over incomplete routes. And we have local preference and atomic aggregate. So local preference, and by the way, those are not mandatory, guys. A local preference, that is a value used to prefer one exit point from the AS over others. So higher values are preferred. And this one, local preference, influences outbound routing decisions within the autonomous systems. So routes with higher local preference are preferred for outbound traffic. And lastly, we have the atomic aggregate, that is an attribute used to indicate that the route was aggregated and that some information may have been lost. So it signals that the prefix has been summarized. So mainly this is used to alert BGP peers that the route has been aggregated and that detailed route information may not be available. The attributes that I showed you in previous slides were the well-known BGP attributes. Some of them are mandatory and some of them are not. And we have optional BGP attributes as well. So the first one is aggregator, that indicates the router and autonomous systems that performed route aggregation. So it includes the IP address of the router and the AS number where the aggregation occurred. So mainly helps to identify the origin of aggregated routes and provides context on route summarization. And we have the community. Those are the tags attached to routes to group and control routing policies. So communities can be used to apply routing policies based on predefined tags. Here the purpose is facilitating route filtering and policy application across BGP peers. So it helps in controlling the advertisement and acceptance of routes. And we have the MED value, which refers to multi-exit discriminator. MED suggests the preferred entry point into an AS for routes coming from the other autonomous systems. So lower MED values are always preferred. Here the purpose is influencing the inbound routing decisions for external routes. So it is used to indicate the preferred path when multiple entry points exist. And lastly, we have the weight. That is a Cisco specific feature and influences route selection within the router. Okay, that is very important. Within the router. It is not advertised to BGP peers. So higher weight values are preferred over lower values, and it is used to prefer certain routes over others on a per router basis. So how BGP finds the best path? So you are saying there are 5 different statements, but I would say even after 5 we have still statements. But usually these first 5 things will be a tiebreaker and help BGP to find the best path. So first of all, BGP rejects the routes coming from inaccessible next hop address for the best path calculation. That is the first thing. The second thing, BGP chooses the highest weight, okay, which is Cisco proprietary, and for example, it chooses the routes coming from one router over another. But weight is a local attribute to the router, is not advertised to neighbor routers, as I told you again. If there is no tiebreaker still, BGP chooses the highest local preference value. If still there is no tiebreaker, if there is a route created by network command, BGP chooses it. Again, still, if there is no tiebreaker, BGP finally chooses the shortest AS path. So this is how BGP finds the best path. It evaluates all the statements starting from statement number 1, then evaluates 2, 3, 4 and 5 to choose the best path. Alright guys, thank you so much for joining me. That's it for this session as well, and let's see you on other sessions.